Hi guys, Mr. Kane here.
Hi guys, Mrs. G.
Good to see you again. Mrs. G, could you pronounce that first word there?
Aufbau.
Bless you.
Thank you. Aufbau Principle.
It turns out Aufbau is a German word, right?
Oh gosh,
Yeah,
yes.
very German.
Looks German to me.
But Aufbau, the Aufbau principle is not something difficult. It is going to use the ideas that we learned last unit with SPD and F.
Okay.
Okay. The Aufbau principle basically is from a German word meaning building up. And what the building up is referring to is how electrons build up in an atom. If you've completely removed all the electrons from an atom, if you add them in one at a time, the building up principle, the Aufbau principle, talks about where those electrons go, which orbitals they wind up in.
Okay.
Okay. So the Aufbau principle basically states that the electrons are going to want to reach the lowest ground state. Yeah, that sounds right.
Because the lower ground state is still closest to the nucleus, is still lower energy, right?
Right. So if I was the first electron trying to get into an atom, I'd go all the way down to the first energy level.
Okay.
Which happens to have an s orbital.
Right.
Right.
Correct.
So I'd wind up in the first s orbital if I was the first electron. If I was the second electron, I could do the same thing, and I could fall into the first s orbital.
Correct. Because it can hold a maximum
Because it can hold a maximum of 2. But if I was the third one, I can't go into that first energy level, the first S.
Yeah, it's filled up.
Because it's filled up. And there are some principles guiding where I would go next.
Okay.
And that's what the Aufbau principle is stating.
Okay, so Aufbau says lowest energy level fills first. Once that gets filled, you're going to have to go somewhere else, basically, correct?
Yeah. Mm-hmm.
So this is kind of like seating at a concert, open seating at a concert. Where would the first person through the door go? Naturally to
Mosh
the front
pit.
row. Yeah, mosh pit, front row. I'm
Front
older
row.
than you.
Same thing.
And once that first row gets filled up, where's the next person going to go? Second row. All right, so the Aufbau principle states the lower energy levels fill first and then proceed back. Is that correct?
Sounds right, yeah.
All right.
Mm-hmm. So the thing is that this is done by the amount of energy, and the amount of energy can be tricky. Okay, here's a diagram of increasing energy and which the energy levels are listed on the left there, 1, 2, 3, and 4, and the orbitals are on the right. Notice 1s is the lowest energy level orbital. So if I was the first electron, I'd be going there.
Right.
The second electron, I'd be going there. But if I was the third electron,
Where are you going to go?
well, the next one up
Is 2s.
is 2s, so I'd go to 2s because 1s is full. So I could go to 2s. And then the fourth one can go to 2s also, but now 2s is full.
Yeah, so where are you going to go? 2p.
Looks like 2p.
Right.
Yeah. So now 2p is kind of fun.
Yeah, well, P
The fifth-
had, if I remember right, P has 3 orbitals, correct?
Right.
Px, Py, Pz.
Right.
Each orbital can hold 2 electrons apiece.
Mm-hmm.
That's a total of 6 maximum.
Mm-hmm.
So 2p can accommodate 6 electrons.
So the 5th, the 6th, the 7th, the 8th, the 9th, and the 10th electrons
Electron
can
can
all
go
go
into
to
there.
2p.
All right,
All right. So then the 11th electron would have to find a place in
3s.
3s. And we don't need to count them all out, but the next one, after 3s is filled, we get to 3p. After 3p is filled, we wouldn't go to 3d, would we?
No, 3D is, we got to go lowest. Aufbau says lowest energy first. So if the 3p gets filled up, where are they going to go?
They're going to go to 4s.
4s is lower energy than 3d. This is hard.
This is interesting. Mrs. G, it's way too complicated to memorize this chart because I know that there are, on the periodic table, 7 levels, right? So I'd have to 1, 2, 3, 4, 5, 6, 7. I'd have to memorize.
We have 7 energy levels, and that's right. Yeah,
I'd have to memorize this crazy skeleton for 7 energy levels?
Yeah,
this is only
tossing me.
4 and it's too hard.
Mr. Kane, I'm a little confused here now. We went over the S, P, D, and F. S is 1 orbital, P is 3, D is 5, and F is 7. Okay. But what are the numbers in front of them?
Those are the energy levels.
So each energy level has a particular orbital possible.
Right, each energy level has certain orbitals possible.
So I'm going to assume, looking at 1s, that the first energy level
only has S.
only has S. There's no P, D, and
Right.
F.
The second energy level has
Only the
S's
S and P.
so it has two types of orbitals.
So the first number tells you the energy level, the second one tells you the orbital.
Right.
And you have to memorize how many lobes, axes, orientations are in that orbital.
How many types? Yeah.
Okay, got it. I don't want to memorize that, Mr. Kane. There's got to be an easier way to do this.
Okay, there is an easier way to do this. It turns out that that device that we've given out the first day of school actually tells us which energy level is next.
Oh, thank goodness.
Okay, now guys, you want to have your periodic table, and you want to label where the S, the P, the D, and the F block are. Notice, guys, that the energy levels on the periodic table are written over here, though. And that correlates to how many energy levels.
Right, yeah,
Right.
we only go up, yeah.
Okay. Now, if this is the S block here, the first atom only has one electron, right?
Which is hydrogen, yeah.
Which is hydrogen. So, it
that
only
would-
has one. It only has electrons in the 1s.
One electron in the 1s.
The
Awesome.
next atom has two electrons.
Which is helium.
Both electrons fit in 1s.
Right.
Where do the next electrons fit?
Goes to the 2s, according
Goes to
your
2s, right?
picture.
So if I read left to right, just like I do in a book, I go to the next line, and there it is, 2s.
Kind of like a board game, isn't it?
It's kind of like a board game. I liken it to a book. You know,
Okay.
you're reading a book, left to right, left to right. I guess it kind of reminds me a little.
Candyland.
Candyland, yeah. You just got to kind of go on. So here's the next electron in 2s for lithium, with 3 electrons. Beryllium has 4, so you can fit 2 electrons in the 2s. Where's the next place to go?
Across to 2p,
Across
which is
to
going to
2p.
take you to boron.
Which has 2p can hold how many electrons total?
Let's
P
see,
for
P
P's?
has 3 orbitals, 2 electrons each orbital, so that's a total of 6 electrons max.
So that means I can have 6 elements in this part of the periodic table, right?
Yep, 6 boxes.
So boron, carbon, nitrogen, oxygen, fluorine, and neon.
So each box on the periodic table represents an electron in this picture.
Right. And the reason why the blocks are as wide as they are, check this out. The S block is too wide because 2 electrons can fit.
2 electrons,
All right.
and that's family number 1 and family number 2.
Right. Over here in the P block, there are 6 atoms across, 6 elements across, because you can fit up to 6 electrons in a P orbital.
I'll bet then in 3D we're going to find 10 elements.
Right. There are 10 elements going across the transition metals. And the inner transition metals have 14 elements going across them. Okay, so it's really easy to be able to tell what they are if you can memorize S, P, D, F, 1, 3, 5, 7.
Yep. Nice. The periodic table, thank you, because that other picture was ugly.
Mm-hmm. So, at any rate, there are some things you got to know. 1s comes first, then 2s, then 2p. Then comes 3s, and notice there are no d's here, so we still don't count the d's, and we go 3p. Then we go to 4s, and when d's finally come in, notice something funny here.
It's 3D.
They're 3D. The 3D exists because, like you pointed out on the last slide, the third energy level has S, P, and D.
Right.
But it turns out that the 3Ds have more energy than the 4S. So they come after the 4Ss.
Yeah, so it looks like all the Ds, let's see how we can phrase this. Looks like all the Ds have slightly higher energy than the previous S's.
Right. So, in other words, on the periodic table, they've been dropped down one position from where you think they should be. So go 4S, 3D, then 4P.
Right.
And then 5S, and we go down for D, so 4D.
4D.
And 5P. And 6S. And you know what? If I follow along on the periodic table, 6S1 is cesium. 6S2 is barium. The next element I should be talking about is lanthanum, which is
down in the 4F.
Down here in 4F. So it goes from 6S to 4F. So the D's are 1 down from where they should be.
Yeah.
The F's are 2 down.
Did you know, Mr. Kane, that the F's, 4F and 5F and 5D and 6D are so close in energy size that the electrons can be in either or? It gets a little dodgy down there. Are we going to stay away from that area?
We're going to predict 1 or 2 of them just for practice. But in reality, yeah, there are some funny things going on
Yeah,
there.
the bottom of the periodic table's tough.
Yeah. And that's one of the reasons why it's difficult to predict some of the properties, like charge of these guys, right?
Yeah.
Is because the energies are pretty similar, and sometimes something weird is going on. So,
Okay.
so now that we know how to read the Aufbau principle,
Okay.
we should be able to write electron configurations.
As long as we remember the maximum number in SPDF, which is what, 2, 6, 10, 14. Maximum number.
Right.
Okay.
All right, so writing electron configurations.
Okay.
Start with the easy one, hydrogen.
Okay, so every electron configuration starts with that 1s, correct? It's kind of like a board game.
Right, yeah, you always say have to start it. Go.
Okay, so you say 1s.
Okay, so I say 1s because I'm in the 1s energy. The first energy level, the s orbital.
S orbital. And hydrogen only has 1 electron, so it must be 1.
Right. Okay.
And we write it just like that. Number, orbital, electron in a, what do they call it? Superscript.
All right, so the first number is an energy level.
Uh-huh.
The next one is my orbital.
It kind of describes the orbital.
And then this number 1 is describing the electrons
Okay.
that are in that orbital. And I'm going to
Okay.
put electrons that way so that they could be 1 or more.
And that's exactly what it should look like.
Okay.
All right, awesome.
All right. So 1s1, yeah, we got that one right. All right, helium. Ha ha ha. Let's see, helium has a first energy level.
Okay, it starts at 1s again, just like a board game,
It has an s orbital,
right?
and it has 2 electrons. Can I put them both in there?
Yes, because that can hold a maximum of 2.
Right, so I can write 1s2, and that would be the electron configuration.
Well, that's easy.
Right, 1s2.
Ooh,
Next,
all right.
Next, hey, this is the third element.
Okay.
All right, this
I
should
got my
be easy.
periodic table in front of me. We start with just like a board game, we start at hydrogen again.
All right, so 1,
S,
s.
2, because 2
2.
electrons maximum.
That takes
Okay.
care of 2 of my electrons.
Right, so now according to the Aufbau, that one's full. We got to go to the next orbital. So the next one, according to the periodic table, is going to be 2s.
Right, 2s,
There
because
is
that's the next block that I
yeah,
arrive on.
There is no
reading,
P, D, or F for the one first energy level.
Reading left to right, I find 2s
All right,
first.
so
Yeah.
we're using strictly the periodic table.
How many electrons more do I have?
1.
Okay.
Ooh, and I noticed, Mr. Kane, that the superscripts add up to the total number of electrons of the element. So you got to start out, so all of them are really going to start out, if we did 118 electron configurations, they'd all start out with 1s2, 2s2, correct?
Yeah, I guess
Every one of them would start out the same.
They'd all start out the same way because they got to start from go.
Yeah. All right, so 1s2.
So 1s2, that takes care of 2 electrons. Let's see, I usually do this, Mrs. G. I don't know if you do this. Some people like to do this. I start with 6. I've 6 electrons because carbon has 6.
Uh-huh.
I've used 2, so now I have 4 left.
Okay.
So what's next?
2s2.
2s2. I just used 2 more electrons,
Okay,
so I'm going to update my number. I've got 2 more to go.
Now that 2s2, that fills up s also. So you got to go to the next one, and according to the periodic table,
I'm looking.
as you go across from beryllium to boron,
That's the 2p block
the
with
2p block.
with boron. 2p.
Boron is 1 box, carbon is 2, so that's 1 electron, 2 electrons.
All right. So I can do it. I can change my number from 2 here. I just used 2 more electrons, so I got none. So I should be done. So using your trick, 2 plus 2
4,
plus 2, 6.
Yep.
That's carbon.
All right, so it's going to start out the same. 1s2,
1s2,
2s2,
2s2,
and 2p.
and then 2p.
Now that takes me to the boron, so 1, 2, 3, 4, 5.
Okay, 5. So let's see. That's 2, 4, plus 5. That's 9.
9. So that's the
Fluorine
electron
has
configuration. Fluorine.
And fluorine has 9 electrons. So yep, that's fluorine. Now that we will predict
Yep, let's
the
do
electron
expected
configuration
electron configuration
for chromium.
24 electrons.
24 electrons. Thank you. Okay.
1s2.
1s2. Okay, so now I have
2s2.
22. 2s2. So now I have 20.
2p6.
2p6. You got to follow the periodic table.
I know, but
Can't go to
just-
3 yet. Sorry.
that's right.
14.
3s2.
3s2. So now I've got 12 electrons.
3p6.
3p6. So now I've got 6 electrons.
All right, now if I stopped right there, Mr. Kane, I'd be at argon, aren't I? So the next one's going to be 4s.
4s,
and 2.
2, so I only have 4 electrons left.
Okay, so now after 4s, according to the periodic table, it's 3d.
So 3d,
Now count the boxes.
One,
Scandium, titanium, vanadium, chromium. 1, 2, 3, 4. That's 4 boxes.
and that's how many electrons I have left. So 3d4 is exactly where we want to be.
So keep in mind, it is kind of like a board game, isn't it? Takes you right to the box where chromium is listed.
All you have to know in order to play a board game is the rules.
Right.
All right, guys, if you think you need some practice with this, try these out. Press pause.
There.
Potassium is 1s2, 2s2,
Oh,
2p6, 3s2, 3p6, 4s1. Manganese is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Yes, they have to be in that order. Copper is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d9.
And they have to look like that. Superscripts for the number of electrons.
And silver is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d9.
Good Lord, do you know what polonium must look like, or statinine?
All right, guys,
Heavens.
for homework, do element 1, number 118.
Oh, no.
And